Good evening and welcome to the nightly edition of your local news station, realtalk.com. Real news, real people, real news people. I'm Real Talk reporter Brad Crookshanks with my co-host here, Ryan McLaughlin, reporting to you live from our Prudhoe Bay, Alaska News Center.
Today marks the 50th consecutive month without any polar bear sightings, setting a new North Slope Borough record.
Folks, it seems we just received some breaking and fairly disturbing news from our field reporter.
We've just gotten word that wellbores have been collapsing simultaneously all over the field. Luckily, we have a reporter in the field right now. Josie, tell us about the scene over there. Is the world as you know it coming to an end?
Yes, Ryan, the world is in fact coming to an end here in Prudhoe Bay. Here I have Clyde Marshall with me, 40-year Prudhoe Bay veteran. Clyde, tell me a little bit about what's going on here today.
Well, I'll tell you what, Josie, it was the strangest thing. I've been working on rigs for 4 years now. I've worked all the way from Saudi Arabia all the way to the North Slope of Alaska, and I ain't never seen nothing like I saw here today just now.
Tell me a little bit about what's going on here.
Well, you see, it was the strangest thing that just happened. One moment, the wells were just sitting there in a row, minding their own business. And 20 years later, boom, they're gone.
Well, you heard it here first. www.realtalk.com. Real news, real people. Real news, people. Back to you guys at the studio.
Thank you, Josie, for that wildly informative interview. We actually have with here right now a technical authority on the matter, Dr. Cradley Brookshanks. Can you break down the situation for us?
Thank you, Ryan, and thank you to the Real Talk team for having me here today. What is happening here is a classic casing conundrum, known to us here in the library as permafrost subsidence. I've brought my associate, Josie Jartley, to demonstrate the phenomenon that we are seeing here today. In this demonstration, the straw is acting as the wellbore, which is supported by the permafrost, or snow in this case. As you can see, when the permafrost melts, the wellbore sinks downward, causing severe compressive forces on the casing. These compressive forces can result in buckling if preventative measures are not taken.
Well, that's great stuff, Dr. Brookshanks. So, what's the verdict? How screwed are we?
Well, unfortunately, all existing wells are beyond help. But there is good news. My team and I have developed an innovative completion technique to eradicate this problem once and for all.
Arctic environments present a myriad of unique challenges which hinder the ability of an operator to produce oil at an economical rate while preventing degradation of soil in permafrost zones. In order to create a safe and efficient system from which to develop Arctic resources, engineers have collaborated to build complex infrastructure systems based on principles of Arctic engineering. The focus of this proposal will be the maintenance of permafrost integrity, one of the unique considerations in the design of Arctic wells. In recent years, focus on the Alaska North Slope has shifted from using primary recovery methods to the integration of secondary and tertiary recovery methods in order to produce heavy oil. Some of the more effective methods include steam injection, steam-assisted gravity drainage, and steam flooding with various gases. Thermal recovery methods result in large increases in temperature of produced fluids and associated heat transfer through the production tubing into the surrounding formation. With increasing heat conduction from the wellbore, it becomes necessary to develop additional techniques to preserve the frozen state of the permafrost. The innovative completion design for this proposal will implement a standard Arctic completion strategy in vacuum-insulated tubing, which has proven to be extremely effective in reducing the thaw of permafrost around a wellbore. Heat transfer into surrounding permafrost poses the risk of creating detrimental damage to wellbore integrity, which can be reversed in some cases only by costly maintenance. In order to abate these damaging effects, a solution has been developed in this proposal that pairs vacuum-insulated tubing and two-phase thermosiphon technology. Currently, two-phase thermosiphons are being used in Arctic environments, most commonly for structural integrity and pipeline subsidence management. Thermosiphons are a tried and true technology in the Arctic, and can also be modified and integrated to a much larger scale for wellbore applications. The use of thermosiphons to reduce thaw of permafrost around a wellbore has been proposed in literature, but is not currently practiced. A two-phase working fluid will be charged into the annulus to take advantage of the latent heat associated with phase change from liquid to vapor. The thermosiphon system will run from the base of the permafrost to the surface, where a packer will be set at 2,000 feet to isolate the working fluid from the lower portion of the annulus. By using thermosiphon technology and vacuum-insulated tubing, a distinct and reliable boundary between warm fluids and frozen permafrost will be created. Eliminating the heat transfer between these two sensitive regions, production of heavy oil with the potential usage of thermal recovery methods can be fully optimized.
Well, you heard it here first. You're listening to www.realtalk.com. And I'm Ryan McLaughlin.
I'm Josie Hartley.
And I'm Brad Crookshanks.
And you're listening to www.realtalk.com, where you get real news.
Real people.
Real news, people.
See you next time.